Greetings once again. I'm really happy to be here to talk about some calculus with you. I want to talk today about minima and maxima. This is in the world of what we call optimization, where optimization means finding minima and maxima of functions. Because oftentimes we want to maximize profit or minimize damage to the environment or minimize the rate of transmission or, so we really want to minimize and maximize the extreme values of a function tend to represent optimal values in some sense. I want to talk about minima and maxima and some labels that we apply to minima and maxima functions. So let's draw a function. Let's do something like that. Let's give this a jump right here for no readily apparent reason. Let's make it go like that. And then let's suppose that it just kind of does like that. Okay. So I got lots of stuff to talk about as far as this particular function. I want to find for you and label for you the minima and maxima of this function. And I want to do that in two ways. First thing I want to do is I want to find with you the biggest and the smallest value over the entire interval. So let's draw some axes. Axes are really good. So here's an axis. The height of this thing doesn't really matter. Vertical translation doesn't affect the locations, just the actual values. So we're talking about a function between A and B. So usually over some finite closed interval that we're going to include the boundary points on this. Okay, fine. Let's see here. We want to find the two places the function is the most extreme. And I think those are right here and right here. So these 2 points right here represent the minimum and maximum value of the function. And we like to apply additional modifiers and not just say minimum or maximum, because we could be talking about there or there also. So I want to apply the additional modifier to those. I'm going to call those the absolute minimum and maximum. And I'm going to put that those are the star. So the star points are the absolute min and max. We also call them global, where it's global relative to the interval A to B, because maybe if we considered a bigger interval, maybe somewhere over here is something that's even bigger or even smaller. And so we do need to pay attention to our interval that we're optimizing over. So absolute is the probably the most common and correct one, but I like to think about global. And the reason is that I would like to label some other points for you also. So let's throw down on this. Let's go right here. Let's put a square right there and right there. And squares are my local minimums. I also like to call them relative mins. But I like the word local because it represents that locally speaking, in a neighborhood nearby to this point, all the function values are bigger right there. So those are the local mins. And how about let's do a circle. I guess I should put a square around that because the absolute is also local. So I'll do squares are, I wanted that to be in pink because I love consistency. local max or relative maximum. So we've got locals and globals, relatives and absolutes. I kind of think that, yeah, whatever. My opinion doesn't matter. Okay, these are the words. These are the words that there are. So absolute means that of all of the locals, it's the biggest. So let me write that down for you. Absolute. An absolute optima is one that is bigger or smaller than all other local optima. Okay? And when I say bigger, smaller, I mean more closer to infinity or closer to minus infinity, because bigger and smaller have these like double meanings in casual language. Because like negative a billion is like a pretty big number in a sense. It's great in magnitude, but it's close to negative infinity. And so we should probably avoid bigger, smaller language and say closer to positive infinity, closer to negative infinity. Because it is possible that 0 is an optima of our function. Okay, so that's the concept of absolute global or local relative mins and maxes. Good luck finding them. We'll talk about that in another video. Thank you so much, and I'll talk to you later. Bye.